Now let's take a moment to compare traditional chemical treatment with CCD, or let's just call CCD a type of physical treatment for now. But before we jump in, it's important to emphasize one thing. This comparison only makes sense when both methods are equally effective in preventing scale and corrosion. Alright, so with that in mind, let's talk about how chemical treatment typically works. This is the traditional method where organic phosphonates are added to the water. These chemicals help form calcium phosphate, which has higher solubility, reducing the chance of scale. And just like CCD, this method also uses the RSI index to manage scale and corrosion risk. Under similar operating conditions, for example, with the cycles of concentration maintained at 5 to 6, chemical treatment requires more supporting equipment. Besides a conductivity controller, you'll also need things like a chemical dosing pump, chemical tanks, an electrical control panel, and a spill tray for safety. On top of that, someone has to regularly refill and maintain the chemical system. In contrast, the physical treatment approach with CCD is much simpler. You only need a conductivity meter to control the cycles. That's it. So when it comes to installation and setup cost, physical treatment like CCD is much lower compared to traditional chemical systems. Now let's take a look at how CCD and traditional chemical treatment compare when it comes to dealing with algae, moss, and other microorganisms. Both methods still require biocides to control microbial growth. But here's the catch with chemical treatment. The phosphonates used to prevent scaling, well, they also act as a nutrient source for microorganisms. So in order to control algae and bacteria, you'll need to add even more biocide. If you're using chlorine-based biocides, that introduces another problem. Too much chlorine can corrode metal parts in your system, leading to long-term damage. Now let's talk about the wastewater. Chemical-treated systems discharge water that contains phosphates, and that can't be dumped casually because once it enters a pond or the environment, it may cause eutrophication, which leads to algae blooms and environmental harm. And what about sludge? In chemical systems, the calcium phosphate that forms can dry up and harden, turning into stubborn deposits inside the cooling tower and on the fill material. That means you'll need to do more frequent cleaning and maintenance. So after looking at all these comparisons from algae control to corrosion risk to environmental impact to maintenance, it's no surprise that once customers switch to CCD, they often say, "This is awesome. There's no going back."